So now it is my real pleasure to introduce to you Dr. Gabe Filippelli, who is the Chancellor's Professor of Earth Sciences and the Executive Director of Indiana University's Environmental Resilient Institute. Dr. Filippelli is a biogeochemist and has broad training in climate change, exposure science, and environmental health. He has published broadly, including notable publications in Science, Nature, and Geology, as well as in specialty journals and in the popular press. He has personally directed over an impressive $9 million of research funding during his career. He is currently the editor-in-chief for the journal GeoHealth, which is published by the American Geophysical Union. He's a fellow of the International Association of Geochemistry, a 2022 Fulbright Distinguished Chair in Global Health, and a former National Academy of Sciences Jefferson Science Fellow, where he served as a senior science advisor for the U.S. Department of State. So it's my real pleasure to introduce Dr. Filippelli to you today, and he will be talking on our keynote lecture for today, using community engagement and citizen science to fight lead poisoning in our communities. Gabe?
I'm going to be talking about a kind of a different way to do science, environmental science that bridges human health. And that is not to do science on communities, but rather with and for communities. So it's a new emerging model. Many of you probably are familiar with terms like citizen science, community-based participatory research, community-engaged science. These are all revolving around the same feature, which is that we can do a better job of improving community health if we work actively with communities in helping frame the questions to be asked. We tend to ask questions from an academic standpoint of things we think a community needs, but in fact, communities often tell us a very different thing that they need. And in fact, they can help bring amazing research discoveries, as I hope to highlight in this presentation. I'm going to focus on environmental health through one lens, and that's lead poisoning. Lead is by far the most dangerous metal on the planet. We used it profligately for 100 years or so in everything from paint to gasoline, to batteries, to other products. But what we've noticed is that it is and continues to be a clear environmental health burden for communities. And it is literally costing minds and costing lives. This is just one snapshot from a Cincinnati lead study where they followed a cohort of kids from toddler age to adulthood. This is just meant to exemplify a couple things, which is that first, these show in this heat patches, the red patches in these brain scans are areas where these people who were tested for their memory and their cognition while they're adults. These red areas are deficits. These are neural deficits. So they're basically effectively neural holes or gaps in the brain. And you notice that I'm not much of a brain doctor, but it is informative that they're almost all in this frontal cortex where humans have their executive functions, right, that government and regulate things like memory, intelligence, and impulse control. What this graphic just stunningly shows is not only is lead significantly decreasing those three functions, intelligence, memory, and impulse control, but remember, these are brains scans of adults who are asked some of these response questions through the Cincinnati lead study. They were not exposed as adults. They're exposed as toddlers. And the shape, the fabric of this lead impact on their brains remains 20 years later, right? So it just speaks to the fact that lead impacts are permanent. And in fact, there's been some studies that show that when you follow people who are lead exposed as toddlers, they continue to lose IQ and economic potential throughout their entire lifespan. So it is truly not just a temporary issue of if you get exposed, you just move kids away and they're fine. In fact, it can be quite serious. Lead is, I think I gravitated toward lead as an environmental problem because it's relatively simple. Lead has the biggest risk factor for lead exposure is being young. Another risk factor is being poor. And I'm going to cover both of those, particularly the poor part, a little bit later on. But lead is riskiest when you get exposed to it in the prenatal to 6-year-old time frame. And that's because our intestines are not fully formed yet. They're not very discriminating. So if a toddler is exposed to, let's say, soil lead, they ingest soil lead, they absorb something like 80% of the lead from that soil, whereas we as adults, it's far less than 20% of that lead, and it's probably as low as 5 in most cases. So they absorb a lot of the lead that they ingest. Their brains are actively forming, right? This is when they are actually building new neurological systems in their brain. We all around this conference are not in the building stage. We're all in the slow decline stage. But this is a very vulnerable neurologic and neurocognitive time for children. Plus, of course, their behavior. I think I know Ben has kids. Several of you do, I'm sure. Kids are gross. They are very close to the ground. They eat about everything, or at least explore with their mouth. So they ingest a tremendous amount of dust and soil. So their net ingestion is much higher. So all of this is a cascade of real problematic issues, and this is why kids are my main focus. Yes, adults can be exposed in occupational settings to quite a bit of lead, and it does cause harmful impacts, but I'm going to focus here on children. The issue of lingering impacts are what I mentioned in the previous slide, that you continue to lose IQ points and economic potential if you're exposed when you're young, because a lot of that lead that shows up first in your blood, it actually gets absorbed by your bones and slowly leaks its way out over your lifespan. I mentioned some of the sources of lead before. Paint and gasoline in this country are big ones. I'm going to highlight an additional source, which is localized lead smelting plants. So this is the typical sources. If you live in a mining town, obviously you'll probably could have mining related sources, but you'll see that that we use a tremendous amount of lead over the last century. It was used in paint for quite a long time. It's been used since the Roman times in paint. But then with the advent of the automobile culture in the United States, and particularly the post-World War II boom, we use a tremendous amount of lead in gasoline. I can go on and on about the fact that there was a much better alternative for lead as an anti-knock agent in the 1920s but I will save that for question and answer if there's interest. So yes, we produce a tremendous amount of lead. Thank goodness for the Clean Air and Clean Water Act, because we got almost all the new sources of lead out of production. However, lest you think that lead has simply gone away because it's no longer being used like it was before, it has not gone away. And it's largely in areas where paint and gasoline and industrial facilities were densest. So it's in old urban cores. It's near roadways. Believe it or not, I do a study, a class project every year with my students where we go next to an old roadway and we take a transect into a park. And you could still see that the soils next to the roadway are about 30 times higher, have about 30 times higher lead than they do in the interior of the park. And they haven't seen a car with leaded gasoline for over 30 years driving down that road. So that's kind of the permanence of this impact. It can be near buildings where it's a combination of lead paint plus the buildings capture fugitive dust and drop it down at the drip line. And so they tend to have higher lead. Near industrial facilities, but here's the biggest issue, is that all of this lead, other than lead and water pipes, it's all in surface soils. We've done a lot of studies now that show that this atmospherically deposited lead, the surface deposited lead from the air, actually accumulates and is concentrated in surface soils. So soils over the last 100 years have acted as this kind of benign sponge of that lead that was deposited, but as in doing so, they've concentrated the lead right up there in the surface where kids play, where dust is generated from, and where we garden. And I'm going to give some examples of why that's an issue. But so that's in text where the lead is now. But what does that look like in reality? Well, this is what it looks like. These are surface soil lead results for Chicago, Illinois, for Sydney, Australia, New Orleans, Indianapolis, even South Bend, Indiana. So these are cities large and small in the US and abroad that all exhibit the same pattern of urban elevation going off to, to relatively low values in suburban to rural areas that were either low density populations, low density traffic, or also simply newer areas, newer developments. So there was no leaded gasoline around anymore, right? Or lead-based paint that had already been phased out. I'm going to come back to the platform that we use to visualize this in a moment, but I wanted to show you what is probably the most promising and most heartbreaking map that I see every day, because I live in this world every day. In about 2013, being frustrated by the lack of access to real life blood lead values for children, what we wanted to do is have a real detailed map so that we can isolate areas that are very prone to lead poisoning and actually attack those areas with science to try to figure out how to mitigate the problem. And those maps are not available typically. We were able to get about 16,000, all of the blood lead tests that were done in Indianapolis from the year 2000 to 2010 and down to the address level. We were able to get that data through a data sharing agreement and analyze it for lead poisoning clusters. And this is what you get. This is a map of lead poisoned children. And it's quite detailed. You can see that there's some disparate areas, and then there's this concentrated. This is downtown Indianapolis. The actual downtown is right here, this green valley where there's no lead poisoning. Well, that's because that's where city county building is, our stadiums, our hotels where nobody has an address in our commercial areas. So beside that, you can see this ring of high blood lead levels around the city. And that corresponds, of course, to what we call the near north side, east side, south side, and west side, right? These are older neighborhoods with a lot of lead paint and high traffic densities, at least past traffic densities. So what's tragic about this map is this is a map of already poisoned children, right? The damage has already been done in this map. And the way that public health professionals view maps or the results that make this is that, okay, here's this child A right here in this one mountain peak. Let's go into that child A's house and try to treat that child. They're not treating the underlying problem, which is environmental lead exposure. They're treating the problem for that one child. So they don't actually use their maps as a way to get ahead of this. It's not saying that they don't want to, it's just simply not in their mandates, right? This is why it is in the EPA's mandates, but the EPA doesn't have these maps. This is why these areas of the environmental science and human health need to get much more closely coupled. Well, first of all, we use this map as well as some models to finally determine that most of this lead exposure nowadays is not coming from kids eating a chip of lead paint off of their old house. It's actually coming from dust generated from soils that might have had degraded paint in it or leaded gasoline, emission remains, but nevertheless it's now in the soil, and that's the main exposure mechanism. So unfortunately, we have a much less detailed map of this lead poisoning from about 30 years before this. And it basically shows the same pattern. High values in the near south, near north, near west, near east. And the sad part of this is that, yes, the general levels of lead poisoning have gone down because of the Clean Air Act and the Clean Water Act, but the same spatial patterns exist, right? So this is what I consider a classic environmental justice story, right? These areas are going unmitigated generation by generation. Families and children are being exposed generation by generation. And we need to stop that, right? We need to get ahead of it. And so I've been putting my passion into doing just that, figuring out novel ways to expand my footprint as a scientist into a footprint as a resource for communities. We started this process by looking at one particular neighborhood. In that neighborhood, we did a deep dive. We worked with community groups and schools and urban gardens to examine soil lead in its community. And it was largely from the context that we were capitalizing on this boom of urban gardening and community gardening that was taking place. And so we analyzed samples from any and all takers. And what we found was kind of some things we expected near major roadways. There's elevated lead. Sadly, near some community gardens, this is a community garden site. There's very elevated lead. And to give you a context, the right-hand scale doesn't show it exactly, but normal soils have about 20 parts per million lead in them. So normal soils. So you can see that almost every one of these is abnormal results, right? We also partnered with a high school, an AP Environmental Sciences program in a high school, and they were eager in taking samples from their own neighborhoods. So they took a bunch of samples, including down here in the south part of this neighborhood, and came back with shockingly high results, like 7,000 parts ppm. The reason it's shocking is not so much that this is an urban value, but that these areas had already been mitigated by the EPA as part of a Superfund cleanup. And what that mitigation did was clean up some areas, certainly. Areas, for example, right here, this was the area of the cleanup, but the site that was being mitigated was a large battery recycling plant right there. And these students came back for 2 straight years and produced this incredible map of a failed environmental cleanup, right? Clearly, they didn't draw the circle large enough to include these communities. And clearly, they hadn't actually cleaned it up properly. This is a bunch of samples from right next to a neighborhood that had very high soil lead. The reason why this was still a problem is that we installed air filters in some of these houses, actually all around this community, this neighborhood, or this portion of the city, I should say. The only values that came up very high for air lead inside homes were right here, an area that had already been mitigated. So that tells us that either there's still a lot of lead in the home, or more likely it was receiving fugitive dust from these unmitigated sites. So this student group was connected to an environmental justice collaborative in this neighborhood, and they said, well, could you contact the EPA and inform them of this? And I sort of turned it on them a little bit because I don't live in this neighborhood. Said, it'd be much more powerful if, in fact, you contacted the EPA. Here's how you go about doing it. Here's some of the facts you'll need, and here's the support you need. So they did, and eventually the EPA begrudgingly came down and did a reassessment, and kind of went quiet for a year until they revealed that yes, indeed, they were going to reopen this site for an additional cleanup. And that cleanup, I'm happy to say, has been completed. So this is a case where if a community has data, they can do something about it if it's actionable. If I had just published this in a journal, which I did publish this in a journal, but if that's where the conversation stopped, if I used data from communities for science only, that's where it would stop. And I think we need to keep with this mind frame is, well, that is one of the 2 things you need to do, right? Because I need to get promoted, right? So that's one thing I need to do. The other thing you need to do is bring this data back to the community so they can take action. And that's what's motivated me to engage in things like developing a new safe gardening initiative where we develop with funding from a local organization a whole pamphlet on how to garden safely in cities. Along with this, it came resources for free lead sampling. So we've provided details for community members of how you go about sampling for lead and how they get those samples to me or any other authorized lab for results and interpretations. And this sort of opened up the floodgates. So since this launch, we have, I think, 2,500 soil lead values from around the city of Indianapolis. And it's helped us engage a lot more with the communities. And in fact, toward the tail end of this project, we made a very direct partnership with 3 local non-for-profits who are in the sphere of community health. And we actually funneled a bunch of resources to their youth development programs where they try to train at-risk youth about various in various skills, and also just to be a leader. And so we funded a whole host of fellowships in these organizations over a couple summers, where we did a little bit of training with the students and had conversations with them about environmental lead and how to deal with it. But then we let them loose, and they sort of developed their own sampling schemes in their own neighborhoods. So they were knocking on doors, and it wasn't me in a lab coat knocking on a door in neighborhoods that are actually really distrustful of government or official interventions, but rather it was a kid down the street. And what they did was they collected a whole host of soil lead values from around these neighborhoods and around the entire city. And what was interesting to me is, first, of those students that were involved in this program, not a single one of them had set foot in a university laboratory until they came into my lab. And so that is something to always keep in mind, is we think people are familiar with this kind of stuff. Well, they're not actually. And second is they come up with some phenomenal ideas. One of them is a relatively straightforward one, is that when you knock on someone's door, they don't want to answer it, right? Or they assume you're selling them something, not trying to provide a service for free. So they developed these door hangers, bilingual door hangers. So they would go out and put door hangers in people's homes saying, we're going to be by tomorrow. So expect us. We'll knock on the door. If you want to participate, here's a little bit of information. That significantly increased the uptake rate of people participating. But what was most fascinating to me is only last year I found out about this, or 2 years ago, is that they took one kernel of information that I provided them and took action all by themselves. And that kernel was that this neighborhood has quite high soil lead values. I know that just from our previous work and then these fellows' work. But I also mentioned that I was really concerned about exposure at unlicensed daycares. A lot of these are like neighborhood daycares where that really accommodate working mothers' time frames, right? They're lower cost than licensed daycares, but they're unlicensed and hence they're illegal. So the last thing that they would want is me knocking on the door and saying, "Hey, can I test your soil for lead?" And so what the students thought is, well, we don't want to approach these areas from a point of blame, like, oh, we're worried you have lead, but rather let's provide them with a service that we know eradicates the lead exposure risk, at least at that moment of time. And that service is simply an extreme mulch over. Like my colleagues at South Bend call it mulch madness. But it's where you simply go to these areas to put a significant amount of mulch down on the playground near the edge of the houses, which tend to have higher soil lead, and let that be a cap, a barrier between the high soil lead and the children above that. Is that a permanent solution? No, but it's a solution for those kids who live there right now and probably next year and the year after, especially if it's maintained. These students had access to vehicles and they got their mulch delivered for free. And of the 20 daycares that they knocked on the door of to provide the services, all 20 took them up on this. So this is a story of how actually a little bit of intervention can lead to downstream outcomes that are beyond the conception of what I would have. I got the stumbling block of their unlicensed daycares. They don't want me to test there. The students were like, well, yeah, they don't need to be tested. Let's just solve the problem. Even if it isn't not a problem in this particular site, everyone wants an extreme mulch over, right? So that was a good example of stepping away from a situation and letting the community solve it. This has sort of led us to providing a little bit of a broader resource. And these are from the city maps that I showed before. We developed a global platform called Map My Environment. You can find it just by Googling or typing in mapmyenvironment.com, all one word. And what this is a free testing service and an educational service for all kinds of environmental issues related to heavy metals, largely. Although we've now gotten into some biome testing, in-home biome testing. And so this is now our main vehicle for recruiting new samples from all over the world. IUPUI, my university, is the North American hub, but similarly, my colleagues at Macquarie University are the South Asia hub, and so forth. We have samples from, like I said, all over the world. North America, now we have about 1,300 soil samples represented. In Australia, they have over 4,000 represented. And we're building this up as we move along. We just dropped in last week all of the United States Geological Survey data, background soil data. But more importantly, we have a lot of city data. So you can zoom in on these maps, click around and provide actually localized information like I showed earlier. And like I repeat here, this is Indianapolis. You could toggle between soil or several new features. We just added a dust layer. So we actually have, I think, 600 dust samples from around North America. We now encourage people to take their vacuum dust, put it in a bag, and we analyze the dust because people spend 90% of their time indoors. So if you do the math, that's where they're most likely to be directly exposed. And scientifically, we're exploring the link between outdoor soil and indoor dust using a bunch of isotopes and stuff. But the people involved don't need to know that. We just simply provide them the results and provide them with some kind of simple tools of how to deal with high values if you find them. We have now just recently expanded this to include water and paint as part of a research partnership and a grant from HUD, where we're actually not only providing the service for free to everyone, but we are specifically providing the service for a group of kids that test within a range of blood lead levels that isn't high enough to get direct services, like a lead intervention, but is high enough to be flagged. So we're trying to provide this citizen science soil testing capabilities to these families to at least provide them with a triage of if we find that peeling paint is a big issue, well, solve that problem. And this is just the way you can use that map to visualize percent poverty or any of the other Census Bureau demographic information. Our most recent work is really fun. We now play with worms. I told you that kids are really gross. Well, they are, in fact, and school kids particularly, they love to pick up worms. And so worms are amazing little biomonitors for soil metal concentrations. So we have a program called Bookworms. And that's with a partnership with a lot of public schools here in Indianapolis, where the youth collect and package earthworms and soil that they found the worms in. We analyze them for the lead. And if they get a certain amount of worms, in a partnership deal with Barnes & Noble's bookstore, we provide them with vouchers for free books. And it's interesting, the reason why we call it bookworms is that they get a free book, right? But one of the only interventions that have been shown, early childhood interventions to counteract the influence of lead exposure, is our educational interventions, reading, for example. And so this is a project that involves the science, right? Environmental detection work that the students are involved with, plus an intervention, a mitigation, which is reading. And I'm super excited by this. It's very simple. We have a desiccant. Students go out and collect worms after a rain and send them in, or really we collect them from schools right now. We crush up the worms and analyze them, and we analyze the soil. And we have a very nice visual to develop this. By we, I want to make it clear that this is really a whole team of colleagues and mostly a horde of students who drive this. And for those folks who are in academics, you'll know that our generation of students are very environmental active, whether it's on climate change or environmental justice issues. So it's tapping into a need that they have as well. Finally, I just need to add in a pretty picture of a bird, not because it's a picture of an American robin, but robins, their main food source are worms. And so we are now analyzing robin blood to make some robin blood and earthworms, to try to make some of these links between how lead in the environment actually can be slightly biomagnified up a food chain. And in fact, we are finding that robin blood has moderately high values of lead, and we're going to use those as another way to map environmental impacts of some of this. The reason why, and I'm going to close this off, the reason why we think this working with communities and environmental issues is so important is that it adds that one piece of pie, which is critical, which is self-efficacy. If our participants were sitting there in the home and a group of white-coated scientists come in and take the samples from their home in their yard and then send them this really obtuse report of their values, Well, they don't feel nearly as engaged in the process as if they actually took the samples themselves. And the report they get is very simple: red, yellow, green. That's what we provide. We provide all the details in the subsequent pages, but that's a cover sheet. We don't over science this, even if we do use the science on our side. And it's true that self-efficacy actually is one of the ways you can build environmental justice back into communities. And if you're interested in that topic, we specifically cover environmental justice from the context of geohealth in a paper that was published in December or November. And please play around with our Map My Environment site, get engaged. You can engage with me on Twitter if you like. If not, just send me emails.